Hi, welcome. We're going to continue going through assignment 3. All right. Draw an NFA for this language. So let's write out this language. It is 0, 0, 1, followed by a 0. And this is a union or a 1, 1, 0, 1. So the way that I'm going to do this is I'm going to do it in the union way. So I'm going to make a lambda transition over to this language right here, and I'm going to make a lambda transition over to this language right here. Now you don't have to do that. You could try to combine it if you wanted to, but this way I know that I'm doing what it's going to be, and it's an NFA, so I can have extra states, I can have lambda transitions, and I'm pretty sure that I could do it without making a mistake by doing it this way. So this language up here is just going to be a 0, followed by a 0. You have to have 2 zeros, followed by any number of 1s here, followed by a last 0. And then that would be accepting. So 0, 0, 0 is in the language, but in there you can have any number of 1s. Then over here, I have a 1, followed by any number of 1s, followed by a 0, followed by a 1. So I feel pretty confident that this is an NFA for this language. I can have lambda transitions. I can have multiple transitions for the same symbol from a state. I don't have to define every symbol for every state in that. And so this is an NFA for that language. All right, let's take a look at this one. So this one is question 5, where I want you to find the DFA. So we want to find a DFA for this, but we're going to go through a procedure to get there, so we practice. So the first thing you do is you draw the NFA, convert the NFA to a DFA, and then see if you can minimize the number of states of the DFA. So first, let's make sure we understand this language. This language is a 0 followed by any number of zeros, or a 0 followed by a 1, followed by any number of zeros, followed by any number of 1s. So to draw my NFA, I'm going to use the same process. I'm going to make lambda transitions to the 2 different possibilities. So this one is going to be a 0 followed by any number of zeros. And the other language is going to be a 0. And again, you might be able to do it without, but I'm going to do it this way, so it's very clear. And now you can't put 0 or 1 here because this doesn't say 0 or 1 star. This says any number of zeros followed by any number of 1s. So once you get a 1, you can't go back and get a 0. So that's why I have this is going to be accepting because I don't have to have any 1s. But if I do get 1s, this is also going to be accepting. So that's how I would draw the NFA for that. So now we will go through the process of converting it from an NFA to a DFA for practice. All right, so now we have our NFA. So now we're going to convert our NFA to a DFA, and I'm going to use the table method to do this. So let's get started. So instead of using Q0, I'm just going to use 0 like I did before, just less writing. So I have state 0, 1, 2, 3, 4, and 5. And I have a 0 and a 1 and a lambda. Alrighty, so we're going to start out with the full table and then get rid of the lambdas. So we're looking at the NFA and we're going to create a DFA, which we already have the answer over there, but we're going to go through the process for practice. So here I have my NFA from Q0 with a 0. I don't go anywhere. I'm not going to put the 0 like this because it's confusing with zeros and ones. I'm just going to leave it blank. But with a lambda, I can go to 1, 3. That's Q1, Q3. From 1 with a 0, I go to 2, and that's it. From 2 with a 0, I stay in 2, and that's it. From 3 with a 0, I go to 4. 4 with a 1, I go to 5. 5 with a 0, I go to 5. I forgot, I have a Q6 here. Okay. 5 with a 1, I don't go anywhere, but I do have a lambda that can take me to 6. And this is a 1, 3. And then 6 with a 1, I stay in 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So I have 9 transitions, so that is correct. So now the next step is to get rid of the lambda. So let's do that. So if I'm in Q0, I can lambda jump to Q1 and then consume a 0 and get to Q2. I can't, if I'm in Q0 and I go to Q1, I don't consume the 0. I have to jump to Q1, then consume the 0 so I can get to Q2. The same thing this way. I'm in Q0, I can jump to Q3, consume a 0, and get to 4. 2 and 4 don't have lambdas, so that takes care of that one. Now my other lambda I have to get rid of. If I'm in 5, I can consume the 0, stay in 5, or I can consume the 0, stay in 5, and jump to 6. So that's a 5, 6 here. All right. If I'm in Q4, I can consume the 1 and get to Q5, and then I can lambda jump to 6. So I could be in Q4, consume a 1, get to 5, and then take the lambda jump to 6. You can see it also in the table. I'm in Q4. I consume a 1. I get to 5, then 5 gives me the opportunity to jump to 6. If I'm in Q5, I can lambda jump to Q6 and consume a 1. So I can be in Q5, lambda jump to Q6, and then consume a 1. So now I think I've gotten rid of my lambdas, and now we should be able to draw our DFA. So the first part that's a little challenging is the initial state. The initial state is not Q0. The initial state is actually 0, 1, 3. Why? Because this whole part right here I can get to from initially starting out because of the lambda jumps. So now I go over here and I look at 0, 1, and 3. So 0, 1, and 3 with a 0. I'm going to try to kind of follow what's over there. Okay. With a 0, so it'll be a little neat. From 0, 1, 3 with a 0, I can get to 2, 4. 0, 1, 3 with a 1, I don't go anywhere. So I'm just going to call that X. All right, now let's check 2, 4. 2, 4. 2, 4 with a 0. So 2 and 4 with a 0. I'm going to go to 2. And 2, 4 with a 1, I'm going to go to 5, 6. All right, let's do 5, 6. Oh, let's do 2 now. So 2 with a 0, I'm going to stay in 2. And with a 1, I'm going to go to X. Now in 5-6, from 5-6 with the 0, I'm going to stay in 5-6. And with a 1, I'm going to go to 6. In 6 with a 0, I go nowhere. And with a 1, I stay in 6. And this state right here, it is a DFA, so you have to be complete. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then any that are accepting, so any that have 2 in it are going to be accepting. Any that has 5 in it's going to be accepting. And any that have 6 are going to be accepting. So it has a lot of accepting states. So this is how then you can try to reduce the number of states. I don't think that the number of states were reducible in this example, but I'm going to move on to the next example. But you could try to, I don't think that it was possible to reduce the number of states. Anyway, I don't remember, but if you could go through the exercise and practice. All right, moving on to the next one. I'm not sure why. All right, so I'm going to stop here and make a third video with the rest of the exercises. So this is a practice question, but I think it's really worth looking at this practice question. So we're going to start by drawing the NFA. So these questions, I wanted you to draw the NFA, convert it to the DFA, and then reduce the DFA. This might not be the most streamlined way to do it, but this is very good practice. So first we're going to understand our language. So what is our language? Our language, we have a 0 and a 1, followed by a 0 or a 0, 1, any combination. And then at the end, we have either a single 0 or a 0, 0. All right, so I'm going to start out my NFA. So the first step is to draw the NFA. So I'm going to start here at state 0. I need to get a 0 and a 1. I'm just naming my states instead of with a Q. I'm just doing it like that. All right, so now I have this little part in here, which I'm going to put it in blue, which is a 0 or a 0, 1. Okay, so I'm going to add these lambda transitions because I want to make a whole cycle around this whole section. So I am going to add a lambda transition here, and then from 3, I could either get a 0, 1, or I could just get a single 0. And then I'm going to put a lambda transition here over to 6. And then I'm going to, because this has this star here, it means I could get as many zeros as I want or none. So I'm going to have to lambda transition over and lambda transition back. So this now you might be able to do this in less states, but you might also make mistakes if you try to do it in less states. So my recommendation is to test a bunch of strings and see if it is working as expected, because sometimes it seems like you're doing it right, but then when you test some strings, you don't have the right answer. So this way I know, even though I have all these extra lambda transitions, that it's that this is going to work. It's very good practice. So we're going to practice turning this into a DFA. All right, then this part over here, I can get a 0, 0, or a single 0. And you could, to make it easier, you could just make this an accepting state, but just for more practice, we're going to add a lambda transition here too. All right, so this is my NFA. It matches the NFA that I gave you, so I'm going to stick with that. It might have been able to be done in less states. NFAs are not always going to be exactly the same, but DFAs should be, because ZFAs are complete with every transition for every state. All right, so now let's draw the DFA. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 states. And we have a 0, and we have a 1, and we have a lambda. So we're going to have some space here because we're actually going to make some pretty combined states here, which I've already given. I think I already gave you guys the answers to this, but we're going to do it together. Okay. And the lambda. All right, so now we got to go through and get all of our states. So Q0 with a 0 goes to 1. Q1 with a 1 goes to 2. Q2 with a lambda goes to 3 and 6. Q3 with a 0 goes to 4 and 5. Q4 with a 1 goes to 5. Q5 with a lambda goes to 6. Q6 with the lambda goes to 2. And Q6 with a 0 goes to 7, 8. And Q7 with a 0 goes to 8. Q8 with a lambda goes to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 transitions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 transitions. All right, so now we need to get rid of these because we can't draw a DFA when we have lambda transitions. So we need to go through the process of getting rid of them. So the first thing we're going to do is we're going to take a look at 0, Q0, state Q0. Doesn't have any lambdas, doesn't go to any states with any lambdas, so nothing's going to change on Q0. Q1. Q1 doesn't have any lambdas, so nothing's going to change for the 0, but it does go to Q2 that does have lambdas. So Q1 can consume the 1 and get to Q2. Once it gets to Q2, it can look down here and it can get to Q2 and it could jump to Q3. So you have to add a 3 here. It also you could be in Q1, consume the 1, get to Q2, and you can jump to Q6. You also could be in Q1, consume the 1, get to Q2, jump to Q6, jump back to Q2, but Q2 is already included. So we did that. All right, so now we're in Q2. All right, so Q2 doesn't consume any symbols directly, but it can jump. So first we'll do the jump to 3. So Q2 can jump to 3, then consume a 0 and get to 4. Q2 can jump to 3, consume a 0 and get to, let's just go here, 4 and get to 5. Q2 can jump to 3, consume a 0 and get to 5. Q2 can jump to 3, consume a 0 and get to 4. Q2 can jump to 3, consume a 0, get to 5, and then jump to 6. Q2 can jump to 3, consume a 0, jump to 6, and jump back to 2. Q2 can jump to, I think that's everything for the 3. All right, so we did the 3. You can jump to 3, consume a 0, get to 4 and 5. You can jump to 3, consume a 0, get to 4, nothing happens from that. You can jump to 3, consume a 0, get to 5, 5 jumps to 6, 6 jumps back to 2. All right. Now, you can also be in Q2 and jump to 6. So you can be in Q2 and you can jump to 6, consume a 0, and get to 7. You're in Q2, you jump to 6, you consume the 0, you get to 7. You can also get to 8. And also 7, 8 jumps to 9. So if I'm in Q2, I can consume a 0, and as long as I consume the 0, I can get to, by consuming 1 0, I can get to 2, 4, 5, 6, 7, 8, 9. So let's see if we are right, and we are not right, because you can also get to 3. Look, I can jump to 3, consume the 0, jump to 6, jump back to 2, and then jump to 3. So I have to also add 3. So I'm going to have a state which is going to be 2, 3, 4, 5, 6, 7, 8, 9. So that state, which is 2, 3, 4, 5, 6, 7, 8, 9, is going to be probably P3. I'm thinking because it's got the 9 in there, it's probably going to be P3. All right, so let's move on to Q2 with a 1. So Q2, I can jump to Q3. I can't do anything with a 1. If I'm in Q2, I can jump to Q6, jump back to Q2, jump to Q3. There's just nothing I can do with a 1. All right, moving on to 3. I'm in Q3. I can consume a 0 and go to Q4. I can consume a 0. Q4 doesn't jump anywhere. However, I can be in Q3, consume a 0, go to Q5, and jump to Q6. And then I can be in Q3, consume a 0, go to Q5, jump to Q6, jump back to Q2, and jump back to Q3. So I can add 2 and 3. I could be in Q3, consume a 0, jump to Q6. So because Q3 is consuming the 0 right here first, it cannot go over to the 7, 8, and 9. So I'm going to have another state, which is going to be 2, 3, 4, 5, and 6, which doesn't have the 9 in it. All right, so let's move on to Q3 with a 1. Q3 with a 1, I can't go anywhere. All right, we got Q4. Q4 with a 0, I'm not going anywhere. Q4 with a 1, I get to Q5. After I'm in Q4 and I consume the 1, I go to Q5, and then Q5 can jump to Q6, and Q6 can jump back to Q2, and Q2 can jump to 3. I'm just putting them in order. So let's see if I can get anywhere else. If I'm in Q4, I consume a 1, I get to Q5. Then I can jump to Q6. I've already consumed the 1, so I can jump to Q6. So I got 5 and I got 6. If I'm in 6, you can even see on the table, I can jump back to 2. Okay, so I added 2. If I'm in 2, I can jump to 3. So I added 3. So this should be 2, 3, 5, 6. 2, 3, 5, and 6. And then 5 can jump to 6. I've already got that. 6 can jump to 2. I've already got that. So I think that that's as far as I can get with a 1 from 4. Okay, from 5. 5, all right, so look what you can do with 5 with a 0. It's the same thing you could do with 2. Because there's a jump here, with 5, I can jump to 6, consume a 0, and get to 8. And then get 9. So I can get, oh, I don't have a line here anymore. So from 5, I can get to 9, and I can get to 8, and I can get to 7. You're in 5, you jump to 6. You can consume a 0, get to 7. You can jump to 6, consume a 0, get to 8, and jump to 9. But I can also be in 5, and I can jump to 6, and jump back to 2, and jump to 3. Now I haven't consumed the 0 yet. Consume the 0 and get to 5. Jump to 6, so I can add 5 and 6. I can be in 5, jump to 6, jump back to 2, jump to 3, consume the 0 and get to 4. I can be in 5, jump to 6, jump to 2, jump to 3, consume the 0, get to 5. I already got 5. Jump to 6, and then jump back to 2, and also jump to 3. So I get that big state again here, P3. All right, if I'm in Q5 with a 1, I can't go anywhere because there's just no way to get to consume a 1 from Q5. All right, we're almost there. Now we got Q6. Q6 with a 0, obviously I can go to 7, 8, and I can jump to 9. All right, but also because Q6 can jump to 2, I don't know if I have to go through it all again, but if I just knowing that I can take the free jump from Q6 to 2, right here I can free jump to 2, I should be able to get everywhere that 2 can get with a 0, which is 2, 3, 4, 5, 6, 7, 8, and 9. All right, from Q6 with a 1, I can't get to the 1. You can only get to the 1 from Q1 or Q4. Alrighty, so moving on to 7. From Q7, I can't go anywhere except to 8 and 9 because I get the jump to 9 and you don't go back. And the 1, you can't go anywhere. All right, from Q8, I don't consume anything. I can free jump to 9, but I don't consume anything. So Q8 is kind of a state that's, not really doing much. Like I said before, you could have combined 9 and 8, but I kept it because it was part of this. And Q9, I don't go anywhere. So now hopefully I did this right and I've gotten rid of my lambda. I'm just going to leave it there in case I made a mistake. It's quite possible I made a mistake. So we're going to start out and we're going to draw our DFA. I'm going to try to kind of follow this just so it's a little neater. All right, so I'm going to start and 0 is my initial state. 0 with a 0, I can get to 1. And 0 with a 1, I don't go anywhere really. So we'll just call this, I guess I called it 5 there. Okay, but I don't really want to do that because I'm going to make these the combined states. So I'm just going to call that state X. All right, now I'm in 1. State 1. State 1 with a 0 is just going to go over here to the X state. But 1 with a 1 is going to go to the state of 2, 3, 6. All right. Now I have my state 2, 3, 6. If I look at 2 and 3 and 6, I will see that with a 0, I can get to P3. I'm going to call it P3 because this is a big number right here. So with a 0, I can get to P3, which is accepting because it has a 9 in it, which is this state here, 2, 3, 4, 5, 6, 7, 8, 9. All right. And from P2, 2, 3, 6, so look at 2, 3, and 6. With a 1, I'm just going to go back here. All right, so my next state is the combination state of 2, 3, 4, 5, 6, 7, 8, 9. And from that state, with a 0, I go back to myself, obviously. And with a 1, I'm going to go to the state of 2, 3, 5, 6. All right, so now I have my state 2, 3, 5, 6. 2, 3, 5, 6 with a 0, I go back here. And from 2, 3, 5, and 6 with a 1, I'm going to go to the trap state. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then, of course, to be complete, because it's a DFA, I have to draw that. All right, then you can go through the process of reducing the number of states, which I'm not going to do, but you will find that you could combine these two states right here, which is kind of obvious even looking at it. With a 0, they both go to P3, and with a 1, they both go to the trap. So, all right, so let's move on to the next example, which is the graded one. All right, so the graded example. So let's take a look at this language. What is this language? So this language is going to have, you have 0, 0, 1. So you must have 0, 0, and then you can have any number of ones. But then you can have that 0, 0, 1 any number of times. All right, so you can have 0, 0, 1 with any number of ones, and then you can do that any number of times that you want. And then after you do that, you're going to end with a single 1. However, you don't have to end with the single 1. You can also just have the empty string. So the empty string is going to be accepting in this language. All right, so my strategy to draw this is to start out here, and really is to deal with the 001 section first. So I'm going to make a lambda transition here so that I can do the 0, 0. Oh, you have 0, 0. Yes. I'm just trying to use the same that I have up there. All right. So this is the same kind of strategy I did on the last one. I have my 0, 0, 1, and then if I put a lambda transition here, so this is the 0, 0, 1 part, which is right here. Then if I put a lambda transition here, then I can, I can jump over it, or I can do it as many times as I want. So I can not do it at all, which at that lambda transition, just skip over it, or I can come back and do it over and over and over again. That's what that lambda transition is right there. So that lambda transition is, those lambda transitions are for this star right here. Then after I do my 0, 0, 1s as many times as I want or don't want, then I can pick up a 1 after that. So I pick up a 1 here, and then I can lambda transition to the final or accepting state. Again, it's not really required. You could probably combine these states together. However, if you did combine them together, you have to test some strings to make sure that it's working, because I know that this works. And it's an NFA. So if we weren't converting it to a DFA, this would be a perfectly acceptable NFA. I can run strings through it. Here's my cycle in the middle of my 001s, and then on the outside is my cycle of the whole thing. All right, so this is this NFA up here. It's way much nicer. So now we're going to do the table method to convert it to a DFA and practice with the lambda. So we already drew this NFA in the last video. So I'm going to now use the table method to convert the NFA to a DFA. So let's get started. So we have 0, 1, 2, 3, 4, 5, and 6 with a 0, with a 1, and with a lambda. So let's draw our table here. Okay. All right, so let's get started. And our first is, we just write out the transitions. So from Q0 with a lambda, I go to Q1. And with a lambda, I go to Q5. Right, yes. Okay, that's all I got. From 1 with a 0, I go to 2. And with a lambda, I go to 4. From 2 with a 0, I go to 3. I think that's it. 3 with a 1, I go to 3. And with a lambda, I go to 4. 4 with a 1, I go to 5. And with a lambda, I go back to 1. And 5 with a lambda, I go to 6. And with a lambda, I also go to 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 transitions. If I count that, I should have 11 transitions. All right, so now it's time to get rid of the lambda transitions. So we start with Q0. So Q0 doesn't consume a 0, but you can jump and consume a 0. So I can jump from Q0 to Q1, consume a 0, and get to 2. All right, see what else I can do. I can jump from Q0 to Q5. However, then I just jump back to Q0 so I don't consume a 0. I can jump from Q0 to Q1, jump to Q4, but I jump back to Q1. So the only place I can get from Q0 by consuming a 0 is to 2. And 2 doesn't jump anywhere. All right, so Q0 with a 1. Q0 with a 1. I can jump to Q1. I didn't consume anything yet. I jump to Q4. I consume a 1. I get to Q5. But you can see that after I consume the 1 in Q5, I can jump to Q6. In addition, after I consume the 1 from Q4 and I'm in Q5, I can jump to Q0. And if I jump to Q0, I can also jump to Q1. And if I jump to Q1, I can also jump to Q4. So basically the only states I can't get to with a 1 from Q0 is 2, which is very obvious. There's no way to get to 2 with a 1. And I also can't get to 3 because I got to go through 2 to get to 3. All right, so now let's see what happens from Q1 with a 0. From Q1 with a 0, I can get to Q2. I could jump over here to 4, jump up back here to 1. That's all I can do. All right, what about a 1? Well, essentially Q1 is going to do the same thing that Q0 is going to do, because if I'm in Q1 and I jump to Q4, I consume the 1, I get to Q5. From 5, I can get to 6 by lambda. From 5, I can get to 0 by lambda. From 0, I can get to 1 by lambda. And from 1, I can get to 4 by lambda. So now we move on to Q2. Q2 with a 0, the only thing I can do is get to Q3. But that's not true, because I'm in Q2, I can consume a 0, get to Q3, and I can jump to Q4. From Q4, I can jump to Q1. All right, so if I'm in Q3, Q2, I consume a 0, I get to Q3. And you can even check on the table here. I get to Q3. Q3 can jump to 4, so I add that. 4 can jump to 1, so I add that. All right, so that's all I can do. And you can even check this here from the table before. When I was in Q1, I lambda jumped to 4. 4, I consumed a 1 and got to 5, so I add that there. But then 5 can jump to 0 and 6, so I add 0 and 6. And 0 can jump to 1 and 5, so I add 1 and 5, and then 1 can jump to 4. So you can get it all from the table, but I think the picture, it's easier to understand. Now I'm in Q2 and I want to do something with a 1. I can't do anything with a 1. Now I'm in Q3. What can I do with a 0? Well, if I'm in Q3, I can jump to Q4. Then I could jump to Q1, consume a 0, and I could get to Q2. And we already know that you can't get anywhere. That's all you can do. All right, now I'm in Q3 and I have a 1. So I can stay in Q3, get the 1, then I can jump to Q4. Q4 jumps to 1. 1 jumps to 4. And I think that that's it. So if I'm in Q3, I consume a 1, I stay in Q3. Then Q3 can jump to Q4. So that works there. Now, what if I'm in Q3 and I jump to Q4 and then consume a 1? So I'm in Q3. I don't consume that 1. I take my jump to Q4. When you jump to Q4, you can consume a 1 and get to Q5, right? So I need to add 5 and 6. And also from 5, I can get to 0. So the only place I can't get is to 2. 0, 1, 2, 3, 4, 5. Yes. So I have another state with a 1, and that makes sense because Q3 is in here, is inside here, and you can't get there with a 1. Only Q3 can get to Q3 with a 1. All right, now I have Q4. Q4 with a 0, I can jump to Q1. So basically Q4 is going to do the same thing as Q1 with a 0, and that is just to get to Q2. Q4 with a 1, I can get to Q5. So I'm going to do, after I consume the 1 and I get to Q5, Q5 can jump to 0 and 6, and 0 can jump to 1 and 4. So it's going to be this same state that's up here. 0, 1, 4, 5, and 6. If I'm in 5 now, I can get to 2. It's the same, right? Because if I'm in 5, I basically jump to 0. So it's the same thing that 0 is doing. And if I'm in 5 with a 1, it would be the same as whatever 0 could do because I get a jump from 5 to that. So it'd be 0, 1, 4, 5, and 6. And from 6, I don't do anything. So now I have, how many states do I have here? I have 0, 1, 4, 5, 6, 0, 1, 3, 4, 5, 6. That's 2 states, 1, 3, 4, and 2. So that's 4 states, 1, 2, 3, 4 states, plus the trap state. So hopefully I did this right. We just need to now figure out our initial state. So the initial state is going to be everywhere you can get from 0 by jumping. So our initial state is going to be obviously 0, but I can jump to 1, and 1 can jump to 4, and 4 jumps back to 1. I can also jump to 5, and 5 can jump to 6. So my initial state is going to be this 0, 1, 4, 5, 6 state, and it is going to be accepting because 6 is accepting. So from 0, 1, 4, 5, 6, where do I go with a 0? Well, if I look at 0, 1, 4, 5, and 6, I can go to 2 with a 0. And from 0, 1, 4, 5, 6, I can stay in 0, 1, 4, 5, 6 with a 1. Now from state 2 with a 0, I stay here. State 2 with a 0, I go to 1, 3, 4, 1, 3, 4. And state 2 with a 1, I'm going to go to my trap state. There's nothing defined right here. So 1, 3, 4. From 1, 3, 4 with a 0, I go back here. And from 1, 3, 4, 1, 3, 4, 1, 3, 4, I go to this new state, which is 0, 1, 3, 4, 5, 6. 0, 1, 3, 4, 5, 6. Okay, that's a 1. Oh, that's a 1. From 2 with a 0 to that's there. That's a 1. I got to label, be sure you label your transitions. All right, so from 0, 1, 3, 4, 5, 6, with a 1. Obviously, I'm going to go 0, 1, 3, 4, 5, 6. I go back to me with a 1. From 0, 1, 3, 4, 5, 6, 0, 1, 3, 4, 5, 6. With a 0, I'm going to go here. All right, so I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 states, and then of course it's a DFA, so you have to be complete. All right, so now we want to see if we can minimize the states. So I'm going to rename the states to do that because I don't want these big long names. So if I go to this next one, we're going to minimize the states. We're going to use procedure mark. I have P0, P1, P2, P3, and P4. So we want to see if we can combine any of these states. So we're going to go through the whole procedure so that we get the practice. You make a half a table here. Why do you make a half a table? Because you don't need to compare twice. So I don't need to compare P0 against P0 because they're the same. And once I compare P0 against P1, I don't have to do P1 against P0. So it's only half a table. So basically I don't need any of this part of the table up here. I only need to worry about these, and then what we're doing here is we're seeing if any of these states could be combined and it would still be a DFA for the same language. So first thing you do is you say, okay, well, P0 is accepting. So if P0 is accepting, did I forget the trap? Oh, I forgot the trap state. Well, the trap state, there's nothing that, I don't think the trap state can be combined with anything, I hope, because I forgot to put it on here. So we can add it, the trap state, but my table is not correct. Alrighty, we will start over. I want to be complete. And of course, it's better to do the full exercise. So I have P0, P1, P2, P3, P4, and the trap, P0, P1, P2, P3, P4, and the trap. So just to go through the whole process, we will include everything. All right, so we start here with our half of a table. Okay. So if it's accepting, so P0 and P2 could not be combined. Oh, I don't have a P1. Oh my. I know, and all of you who are just watching that were like thinking that, okay, so there is no P1. So let's just take that out. I don't know what I did here, but it's okay. So P0 and P2 cannot be combined. Let me get a different color. And P0 and P3 cannot be combined, and P0 and the trap cannot be combined. And P4 and the trap cannot be combined, and P4 and P4 and P2 cannot be combined. P4 and P3 cannot be combined because they are accepting and not accepting. So I could combine P0, P4, those could possibly be combined. That's this one right here. I could possibly combine P2, P3, that is right here. I could possibly combine P2 and the trap, that's right here. And I could possibly combine P3 and the trap, and that is this right here. So then you just go through and you check. So if I were to combine P0 and P4 with a 0, where do they go? P0 with a 0 goes to P2. P4 with a 0 goes to P2. So that looks like a good chance. Where do they go with a 1? P0 with a 1 goes to P0, and P4 with a 1 goes to P4. So there's a very good chance that I could combine P0, P4 because the new state would be, it would go to itself, and the other state, it would go to P2, and P2 can be combined. So yes, I can combine P0 and P4. Let's check the other ones. Can I combine P2 and P3? P2 and P3, P2 with a 0 goes to P3, P3 with a 0 goes to P2. So far so good. How about with a 1? P2 with a 1 goes to the trap. P3 with a 1 goes to P4. Now I can't combine the trap and P4. They cannot be combined. So since the trap and P4 cannot be combined, that means that P2 and P3 cannot be combined. All right, so now let's check P2 in the trap. P2 with a 0 goes to P3. The trap with a 0 goes to the trap. P3 and the trap so far could possibly be combined, so that's not a deciding factor. What about a 1? P2 with a 1 goes to the trap. The trap with a 1 goes to the trap. So at this point, I can say, oh, maybe there's a chance I could combine. As long as P3 and the trap can be combined, then I can combine P2 in the trap. So let's see what happens with P3 in the trap. P3 with a 0 goes to P2, and the trap with a 0 goes to the trap. So far, potentially, P3 with a 1 goes to P4, and the trap with a 1 goes to the trap. Well, I can't combine P4 and the trap. There's an X here, and they cannot be combined. So since P4 and the trap cannot be combined, that means that P3 and the trap cannot be combined. And since P3 and the trap cannot be combined, that means that P2 and the trap cannot be combined. So the only ones that can be combined is P0 and P4. So I can redraw it. I don't know if I have another slide with this. I'm going to, I don't think so, so I'm going to redraw it. So this would be my P0, P4 initial state with a 0 goes to P2. With a 1, it stays here. P2 with a 0 goes to P3. P2 with a 1 goes to the trap state. P3 with a 0 goes back here. P3 with a 1, of course, if I was going to do this, I would definitely redraw it better. So let's just put the trap out here. P3 with a 1 is going to go back there. And I think that that's it. And then we just have to put the 0, 1 on the trap. So we have our new minimized DFA, and we went through the process, we practiced, and that's the whole point of this assignment, was to practice. All right, we just got 2 more. This is very straightforward. How do you construct a DFA from a grammar? So this is, I just want to tell you a little bit about this grammar. This is a linear grammar because there's a single variable on the left and a single variable on the right. And you know that this is a regular language because this is a right linear grammar. And why is that? It's because every single variable that is on the right-hand side is all the way to the right. So if you had a production that looked like this, then it would not be a regular language. So that's something that you need to know. All right, creating a DFA from this is very straightforward. You just start out and you label the states with your the sample solution I gave you I think is not a DFA, but that's okay. I'm going to make it here. It will be a DFA because I didn't make it complete. So you label the states and then you just do the transitions. So with an A, I'm going to get to this state. I'll just label it X. because since there's two letters here, I need to make a state in between, and then I get to A. All right, then from A, I would do a B, let's call this Y, and an A to get to B. And then with an A, I'm going to go back here to there. And with a B, I have to get two B's. So I'm going to get a B. I'll call this Z, and another B, and call this K. All right, so this is going to be my accepting state. But I just realized that I gave you guys this as the answer, and I'm wondering if anyone's going to point it out. This is not a DFA. The reason it's not a DFA is because all transitions need to be defined from every state. So this is actually an NFA. So we need to turn this into a DFA. The thing that's nice is we can probably turn this into a DFA by just adding transitions out. Let's put this over here. And adding a new, like a trap state. So let's see if we can do that. We can add a trap state here. So from here, I have a transition defined for A. So that means for a B, I have nowhere to go. For here, I have a transition defined for B. So for an A, I have nowhere to go. For my A, I have a transition defined from here for a B, but I didn't define anything for the A. For this Y state, I have something defined for A, but not for B. From the B state, I have A here, and I also have B, so I don't have to, that's complete. From this state, I have a B, but not an A. And from this state, I don't have anything defined, so I'm going to go, if after I create my strings, if I get any A's or B's after that, I'm going to go to the trap state, and then I need to put a transition here on the trap state. This makes it a DFA. So those of you, this is a practice question. So hopefully someone will point it out, and I will notice. I would be happy if someone noticed, because on the sample solutions document I posted, I did not make a DFA. I made an NFA. It's no longer an NFA. All right, last question. This one is graded, so it needs to be a DFA. So let's get started. We start here, S. With an A, we're going to go to A. With a B, we're going to stay here in S. From A, with an A, we're going to go to B. And with a B, we're going to stay here in A. From B, with a B, we're going to stay here in B. And with an A, we're going to go to X. And right here, we have to terminate at some point and produce strings. So this is our accepting state. And then this is actually our trap state. So we have an A and a B. So this is actually a DFA because I have every transition defined from every state.